Okay, today we're back on question 8. And I forgot everything. Forgot everything I'm supposed to be doing. So I'm just going to restart it. And then if we get lucky, we might get through. We might get to read the next chapter, assuming that I can't do any questions after that. I mean, that's kind of unlikely, but we'll find out. I mean, it's unlikely that I will get through it, not that I won't be able to do any questions after it. So, where were we? Question 8. Here's where we're at. That's not very good. (8a). Prove the following theorem of Nicomachus by induction. Hello, Atom Fighter. How you doing? So, last time we made some progress on this, but we didn't solve it, and I forgot most of what I was doing. So, we're gonna find out. You think you're exhausted or you've yet to break fever? Oh no, are you sick? Hate being sick. Sick-ish, maybe. I'm sorry to hear that. Alright. Well, we've proved P1. And our goal is going to be to prove something like if P1 through Pn then P gosh, terrible typing. Pn plus 1. Body aches, sore muscles, and you feel slow. I'm sorry. I hate that. I hate that feeling. Every time I get sick, I feel like I'll never get better ever again, and then I do. And I'm like, oh, that's okay. So I'm hoping for that for you soon. Yeah. Hello, Lorsayer. 20 stream streak? That's crazy. That's crazy. Thank you. That is crazy though. 20 stream. I mean, that is more. That's a lot of progress even in that. I always feel good when I get to like 3 stream streaks on anyone. All right, now one of the questions of last time is how do we go from, so this is like our problem, this is just going to be scratch work. How do we go from what was it? Yeah, it was n cubed. How do we go from n cubed to n plus 1 cubed? And I and Happy Nora solved this separately. Happy Nora solved it better than I did. Crazy if you only streamed 8 times. Yeah, that would be crazier. And we solved this. We solved this thing. Let me see if I can get it working again. Now, the way I worked it out was I had a little diagram of a cube. So we can start off with like 1, right? And then if we wanted to go to 2 cubed, which of course would be like Windows, like Microsoft Windows cube. What is this torture that Knuth imposes on us? I hope that it will be worth it at the end. I hope it'll be worth it on the end. At the end. So to do this, how did I do this again? Yeah. So imagine that this cube here is around the back. And we've got to add all the rest. So the first thing we want to do is add in this side. And that is going to be, in this case, it's going to be 2 squared. Talinch, hello. It is kind of amazing. Magic of math, the math of magic. I did never say that again. Okay, so we get this side here. And that means we've got this. Actually, all these are the same cell. We've got all this. And then we've got 2 more things to add. You know, funnily enough, this reminds me of, I was watching a video called Piaget on Piaget. I think that's how you pronounce his name. I learned that recently. And he has a little experiment that he does where he experiments on children a lot. I know that sounds bad, but it's fine. Basically, the experiment goes like this. See if you can do it. See if you have the expertise of a approximately 11-year-old child. They're given a blue board. So imagine this is all blue, and that represents the ocean. And then on the ocean are some islands. So for example, here's one. And this island it's got like a block on it. Like this. It's kind of tall. And if you put this block onto this square, then it fills the square entirely. But it's like taller. It's about, let's say 3 units tall. And then there's another island over here. And this is actually about, so this let's imagine actually that this is like 4 units high and this is 3 units across. This is what we know. The children don't know this, but I'm just describing the scene to you. So this block is on, the psychologist puts the block on here and it's like, cool, see that? You see, we want to build houses on these squares, but you can't build in the water, of course. We know that. So the block can't go outside. When you place it on here, it can't go outside of this box, right? Which is fine with this box. But here the box is quite thin. It's actually about 3 units high, or 3 units like long, let's say, because this is flat, and 1 unit across. And then the child is given lots of unit cubes and is tasked with, okay, we want to make a house on here, which is just as big as this block, just as big as the house here. So this house is like, I don't know, 4 by 3 by 3. And obviously the child can't just make the exact same shape, right? And if they're going to put the same, if they're going to make a house of the same room, given that the house will have to be narrower because you can't build on the water, they're going to have to make it taller. And the interesting thing, as you will see, I'm making a little video about this for the second channel. The reaction of the children is quite interesting. The children generally don't get this until, I think, like 8. But that's like a lot of Piaget's thinking. Like, children go through these stages where they learn about physics, essentially, in their own childlike way. So they start off just like building something that is exactly as high as this, and they get the idea that if it's as high, it's the same amount of room. And if you ask them, is it the same amount of room, even though it's like really thin, they're like, yep, because you can see it's the same height. It takes them a while, and they go through some intermediary stages to work out like what conservation of, I guess, what volume is, what conservation is. Already eating the marshmallow. Okay, yeah. Yes, no marshmallow. You'll just have to eat the blocks. Sorry. Don't eat those though. They're a choking hazard. Anyway, so this is reminding me of that. Having to do something kind of similar. Anyway, enough of Piaget. All right, so then now the reality is that we have to add 2, and then we have to add 1, because we've got to add these ones, these 2 here and this here. And if we were to try to repeat this again, we might start to notice a pattern. Probably you could figure this out yourself if you wanted. But I'm just kind of loading this whole thing back into my brain, so I'm going to do it manually. Oh, that's not quite right, is it? That'll do. Okay, so if we want to do this, we've got to add in, or clearly we've got to add in 3 squared, because that's this size, this side. Let's say this side here. Then we definitely have to add in, oh, my colors are messed up. We have to add in we could say 2 lots of 2 squared. We could say that. That would work with this pattern as well. And then we have to add in 2. Then we've essentially gone for these ones twice, and then we've added in these 2 here. So maybe the pattern is n plus 1 squared plus 2n plus n? No, 2n squared plus n. Could be that. It might not be. Just wondering. Let's try and expand this out. So we've got n squared plus 2n plus 1 here. Then we've got 2 squared plus, sorry, we don't. We have 2n squared plus n. Yeah, I think that's right. So that gives us, okay, first the n squared, that's 3n squared plus 3n plus 1. Sorry, 3n squared. No, 3n. 3n. Okay, does that work? Now, it might... Let's see if it works for 1. So, of course, 1 squared is 1, 2 squared is 4. So, let's try 3 times 1. This is not going to work. So that's 7. Clearly wrong. All right, so it's not that. What's it supposed to be again? Let's go back and look at this again. Let's try another way of looking at this. So we definitely need... I'm almost certain we need the n plus 1 squared. Then if we want to look at the top face, we could look at this as 3 by 2 by 2 maybe? Minus 2? We do need drill blocks. Hello, Check94. That is a good question. So this would make this n plus 1, I think. Minus n, maybe? Would this get us anything for 1? So that would be 2 squared plus 2 multiplied by 1 multiplied by 2 minus 2. So that's 4 plus 4 minus 2. That's 6. Wrong. No, actually that is not right. What is 2 squared again? 4. Oh, it's 2 cubed. What am I doing? Oh my gosh. It's 2 cubed. It's 2 cubed. How long have I been working with the idea that it's cubed? Oh my gosh. Okay. 2 cubed is 8. 2 cubed is 8. 2 cubed is 8. Okay. Right. 2 squared plus 2 by 1 by 2 minus 2. Is that right? I'm messing this up somehow. Minus 2 is messing me up. No, that can't be right. What am I even doing here? Okay, so we got this 2 squared. Now that's right. And yeah, no, I am doing it wrong. And then we've got 2 by 1 twice. Oh no, wait, I haven't counted the original block. That's why. What am I doing? Yeah, I think I just mentally discounted this block because I'm thinking in terms of what we need to add. But that's not right. So actually, maybe this does work. So this should be 2 by 1. Let me do it properly so I don't make any other mistakes. by 2. Well, it's a 1. You know, I'm just going to actually just do this properly without trying to do a million things in my head at once. 1 cubed to 2 cubed. 1 cubed is 1, 2 cubed is 8. So that's what we should get at the end. Right, and so we're going to have 1 plus 1, need to conform my 1s, squared, plus 2 multiplied by 1, multiplied by 1 plus 1, minus 1. Now I think this is going to get a 7, and I actually probably need to add an n onto the end here, because I've just sort of gotten the wrong thing, but I think adding an n makes it right again. And when we simplify this, it won't matter anyway. So yeah, so obviously that doesn't matter. But then what have we got there? Anyway, think just the one thing at a time. 2 squared plus 2 by 2. Right, so for this one, it's going to work. Now for 3, I think it's not going to work. For 3, we've got to be smarter. So for 2 cubed to 3 cubed, that's going to be 8 to 27. 3 times 3, 9. 9 times 3, yeah. Okay. In which case, we're going to have 2 plus 1 squared plus 2 multiplied by 2 multiplied by 3. Yeah, that's 2 plus 1. And then we got that stuff on the end, which I've forgotten what we need to do about. Let's see what this turns out to be. So this is going to be 3 squared. That's 9. That is the first face there. Then we're going to add these 2 faces, and that's not even right. That doesn't make any sense anymore. But I think I can adjust for it. So here we've got, wow, this is such a silly way of doing this. Okay, well, we've got to keep going now anyway. So that's going to be 4 by 3, which of course is 12, and that gives us 6 plus 6. Great, then we need to subtract that n, which is the overlap. Then we need to add n squared, the original thing that we're trying to go up from, which I just discounted for some reason because I just wanted to think about growth. I don't know why I did that. Oh my gosh. Wow, I really am warming up today. Okay, so that's 2 squared. What do we get? 9 plus 12 minus 2 plus 4. 21. This is not going to be right. 19. No. It's cubed. Plus 8. 27. Oh my gosh. Oh, what an ordeal. Okay, so this is something like the right formula now, although it's like a complete mess. Study geometry, K. Right. So, if only an Kleinbot was here. Hello, Happy Nora. Right. I'm rederiving the formula we derived, or you derived and I derived separately worse last time to try to get it back into my, load it all back into my brain. How are you doing, Happy Nora? Two N, 4N, 3N. Maybe this? It's cooled down. That's good. I've been working on getting my laptop to cool down while doing this, and I think everything is generating quite a lot less heat now, and there shouldn't be quite as much trouble this stream as there was last stream. So far we've dropped 0 frames. Very exciting. Okay, let's try this for 3 cubed to 4 cubed. So this is really trying to get to n plus 1 cubed. That's what we're trying to get to. And I know that I happen to know now that there is a somewhat well-known formula for this, I think. But I've forgotten it again. But I now know it exists, which is progress. Okay, so this is going to be 27. And this is going to be 4 times 4 is 16. Let's work this out. I've also got a new keyboard. Very exciting. 64. Should know that. It is 64-ish. Okay, so we've got 3 cubed plus 3 times 3 squared plus 3 times 3 plus 1, which is 27 plus, running out of space, 27 plus 3 times 9, should know that, 20, no wait, 3 times 9? It's 3 times 9 again? 27. Oh, of course, because 3 cubed is 27, that makes sense. I was surprised by them being the same number, but it actually makes complete sense because 9 is 3 cubed, so that makes sense. Hello, S Destroyer. Always good to have your support in the chat, S Destroyer. Okay, and then 9, and then 1. Now, is this right? 27 times 2 is... Okay, so that's going to be 40 plus 14, so that's 54. Plus 9, plus 1 is looking good. 54 plus 9 is going to be 63, plus 1 is 64. Yeah! Alright, it appears to work. Max Sylvester says, binomial theorem gives the expansion for a plus b to the power n, and the coefficients can be calculated from Pascal's triangle. Did you say that last time? I feel like definitely somebody said that last time. That's true. Yeah. I learned the sum of it also is like 2n or something. Something like that. Max Sylvester, that is useful to know. Are you telling me that as because it would make this faster, or because it directly solves the problem of like n cubed to n plus 1 cubed? Because that's, I'm not seeing how that... I suppose if you no, I suppose I get it. If you calculate it for n plus 1, yeah, I suppose you can look at this as a special case of a plus b. And then you've got, of course, you've got all those 1, 3, 3, 1. I see. So that would be, yeah, okay. I get it now. So we'd be looking at 1 times, you know, x cubed. Well, it's actually 1n cubed multiplied by 1 to the power 0. So we're ignoring all the 1s essentially. Yeah, and then the 3 n squared plus 3n plus the 1 and the n0. Okay, I see how that applies. I didn't get that last time at all. Thank you. Thank you for saying it again, if it was you last time. Right, well, if you're wondering why things take me so long, there's your illustration. We're just half an hour in. Okay, so we got that. Great. Now, the other thing we were doing was working out what the sequence is. So we've got a bunch of rows. We've got for the row 1, make a little diagram here. Actually, let me change the color. We get 3, 5, 7, 9, 11, then 13, 15, 17, 19. And let's put this in like terms of n. I'm going to work out a way of drawing straight lines, by the way. So here we've got we've actually got 1n. So we've got 2n minus 1. No, we don't. No, we do. Plus 1. As I'm told, is the way to represent odd numbers. Here we've got 2n minus 1 again, maybe? So that would be 2 by 1, so it's 2 plus 1. And then we've got 2n plus 1. And then here n is 3, so we've got 2n, 2 times 3, 6, plus 1. Not looking good for our sequence here. Two times 4 plus 1, 8, 9. And then here we're going to have two n plus 2. So this clearly isn't the right form. And then it's like da 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 da. And then we've got 2. Well, it's got to be plus 2, plus 3, plus 4, plus 5. So that's 2, 9, 18 plus 1. Doesn't go very easily in terms of n in that form, but there you go. Tells us something. What does it tell us? Well, it tells us that we can't easily go from n to that to those odd numbers. At least not in that form. There's got to be some other way of going from n to those numbers. Could it be the square? Could it be related to the square in some way? Uh, 2 squared 4. Hello Fico, how you doing? So let's look at just this one. Now this one is, so the sequence here is 6, 7, 8, 9. 4 squared is 8. Doesn't seem to relate to anything. Maybe we don't need to have a way to go from n. I suppose we don't really need, we kind of need to. Well, actually, maybe we don't. Like, another way of thinking about this, I suppose, is so if we're trying to prove, like, if we're trying to use induction, right, we might not need to go from n to those numbers. But we do need to be able to go from like 7, 9, 11 to 13, 15, 17, 19. Now, one way of doing that would just be to take the last one, but I don't know of any particularly nice way of doing that without obviously having a programming language involved. Maybe that would be fine. Well, let's look first if there's some relationship between this and indeed between the 7 and Is it before the 3? And then I guess we may as well think about the 1 as well. Now this is 2, 4. Not a nice sum for me. 13 minus 7, 6. Okay. Good afternoon from Ecuador. Good afternoon from the UK. What's the weather like in Ecuador today? So, okay, this gives us a bit of hope, maybe. No. They're all the same offset. And then there's this one. The extra one. So, can we go from one sequence to the other? Let's say if we've got... I don't know, n... Let's not call it n. Let's call it A. Let's call it something easy to draw. B. Yeah, B. B plus 2. Let's say we've got that. Let's say we've got just that, actually. And that's going to represent this sequence here. And then we're going from... So this is the sequence for... three, and this is the sequence for 4. 2, 1. So we're going by 2n. So to go from here to the next one, maybe we add 2n. So if we're going from 3 and then 5, we add 4, which gets us 7 and 9. And then we have to add something on the end. We've got to add in... How would we get the final number in there? Well, it's got to be in some way related to n plus 1 cubed, right? Did I change my username, Bedro? No. Wait, maybe I did. On Twitch? I don't think so. If it was, it wasn't recently. Let me check. I did actually get defrauded last week. No, same username. I got defrauded last week. It's bad news, everyone. It's become. I should have done like a Tim Rogers stream, and talk about being defrauded. I feel that Tim Rogers would talk about that. If Tim Rogers was defrauded, we would know about it on stream. I love Tim Rogers. I should say I'm not a hater. I'm a lover, but yeah, I was defrauded. I was defrauded out of a significant amount of money, actually. Well, significant depends on who you are, I suppose, but significant enough. It was kind of crazy. It's not happened to me before. Yeah, maybe. Okay, so this last one. Like, I suppose we could call it... Like, in a way, it would be kind of handy if we could add something onto the start. But I guess there isn't any order in this, because we can just put it on the start anyway. But if we did that... though... Maybe it would be kind of neat, in a way. Because if we did that, would we get something a little nicer? And then what would this first term be? Kind of the same problem, really. Well, worth thinking about anyway. All right, what can we do with this last term? Maybe we can just work out what it should be and then just figure it out. So if we've got b and b plus 2, like what we're actually ending up with is b plus 2n, b plus 2 plus 2n, and then it's like b plus 4 plus 2n, and that takes us from n equals 2, for example, to n equals 3, but we don't necessarily know the length of that. Well, I guess we do actually. The length is n. The length is n, so that's kind of interesting. Maybe we could do something with that. So this sequence, maybe we could write it as it's not related. Let's say it's b plus 2, comma, 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 and then it's like two times 2, right? No, 2 times n. b plus 2n. We're adding as many 2s as there are. No, it's actually plus. It's plus something else. It's plus oh, okay, getting confused. I think that's where we end up. So if we start at 3, we add 2 by 1 to get to 5. If we start at 7, we add 2 by 2 to get 4. 7, 8, 9, 10, 11. Okay. And then with this one, it's 2 by 3. So 6. Yeah, okay. Great. Estesora says, I don't know why you're doing all this. Just write the assumed result for n and then expand one of the sides, it'll cancel out. That's probably a very good idea. I'm doing A. Footlong Icicle, sup to you. It's like a reunion in the chat today. What channel do you usually all hang out on? Or are you in some sort of secret society? All right, so that's like the sequence. Oh, Bedro's channel. Oh, or Janet's. Yes, I've been in Janet's chat. Uh-huh. What do you? So you stream Bedro? Of course you do. You've got Nitro. The only people who get Nitro. Sorry for doxing you. I should know better. Turbo. Yeah, I hate ads too. What do you stream, Bedro Dev? I guess you stream dev stuff. Web dev. Nice. Nice. And what are you working on? The web, I guess. Have I been in your channel? I don't actually know. I might have been. God damn, this new keyboard. I'm trying to like... Oh, okay. No, I've messed everything up. I'm trying... Oh. I hate Twitch so much. No offense. Yeah, I just can't use my computer. And whenever you load up Twitch, it loves to just play stuff at me. You like breathing? That's me too, actually. Here's some proof. Never doubt. Last project was a mobile app, QRU. It's for sharing contact details with QR codes. Nice. Cool. About to make a comeback. Well, everyone go follow. Let me see if I can use my keyboard well enough to do this. If you're going to hang out in this channel, then you've got to be... Okay, will this work? No, I can't. Just can't do anything. I'm going to make it work. Yeah. Yeah, we're doing it. We're doing it. We're doing it. No, you didn't. You didn't, Bedrodev. You, I forced you into it. Go follow. If you follow if two of you follow, then Bedro will get to 90 followers. So go make that happen. Oh, the V card. Oh yeah, V card. Okay. You scared me there, Death Destroyer. I thought I was supporting the wrong kind of channel. No, the only wrong kind of channel is that mouse. Unless you're the mouse, Bedro Dave. I hope you're not. We all know about the mouse here. Okay, now where was I? Okay, so to go from one of these to the next, we're going from n cubed equals b. We don't know how to get b, but we don't care. We don't care about that. Plus 2n b plus 2n plus 2 all the way to that's definitely not right, but let's write it down now just in case. Yeah, I mean that looks like a very dubious sequence, doesn't it? But maybe we can do something with it. Let's destroy it. Let's destroy this. They should call you Ego Destroyer. Wait, is this the same problem from a few streams ago where you were writing the Sigma starting point wrong? I started it on last stream. So, not from a few streams ago. No, wait, this is not right. That's not right. That's definitely not right. That's one of the reasons it's not right. It's b plus 2 all the way to b plus 2n minus 1. So maybe there's an n in here. It would make sense, right? Well, anyway. And then we go to b plus 2n b plus 2n plus 2 all the way to b plus 2n and then this must be something. It must be 2n minus 1, maybe? Well, actually, this n is going to be different now, isn't it? Yeah. Wait, what's that going to be? Ugh. It's going to be something. It's probably going to be... I mean, it could be 2n. All right, let's try out that. Let's see whether we get anything out of that. So, let's start from 3 and go to 4. And this is going to be 7 plus 9 plus 11. And then we're going to 4 cubed. Now this is b. So b plus 2n. 7 plus 2 by 4 is 8. So that'll be 15. Wrong. And also, yeah. But close. We've got to go up by 6. Oh no, actually this is n plus 1. So actually it is n. It's b plus 2n. It's 7 plus 6. 7 plus 6 is going to be 13. Let me write this down. N equals 6. Loser. Okay, so that's b plus 2n. b plus 2n plus 2. And then we're going all the way to... This is clearly wrong now, because that's the starting term. It's plus something. It's got to be plus something in terms of n. 4 by 2... plus another 2n? Well, it makes sense. But it'll be 2n plus 1. Right? Maybe? Okay, what's the last term? 7 plus 6, 13. Plus 2 by 4, which is 8. Nope. Wrong. It's a little too high. So it's actually just n, I think. So it's 13 plus 12. Interesting. No. It's plus 6. It's plus 6. So it's 7 plus 12. Right. So it's plus 4n. I think. So this is actually going to be plus 4n. All right, 7 plus 12, 19, and then we have the 17 in the middle. Okay, that takes us from one step to the next, which is going to be important for us to do the induction. big news, everyone. Big news. Follower goal met. 2,000 out of 2,000. I'm not getting the information. I don't know who it is. Maybe I'll be told. But if you just followed me, thanks for the 2,000th follow. An exciting day. Oh. Oh. Oh my gosh. Right. So let's neaten this up a bit. It's b plus 4n. So we're kind of going up from as would make sense. We're going up from 2n to 4n in twos. In steps of 2. And there are 4 steps. So each step is going to be 2n. Well, there are n plus 1 steps, really. I don't think this is in any way useful for us, but right. So can we put this a little bit more algebraically? This one's a little troubling because it's not directly transferable. Can we make it directly transferable? If this was 2n, it will be much nicer. Let me write that out again. And probably there is a way to put b in terms of n. We know that we've got 1, 3, 7, 13. And that's 2, 4, 6, and presumably this would be 8. Let's hope. Maybe it's n by n minus 1 related. The next one's 21. Which would make sense, because then we'd have 4 by 5, which would be 20 plus 1. And I'm pretty sure these are all 2 by 3, that's 6 plus 1. 1 by 2, that's 2 plus 1. And then the first term, yeah, that seems to work. So the sequence then is n by n minus 1 plus 1, then n by n minus 1 plus 3 up to n by n minus 1 and this is going to be related to n. It's as many 2s as we've got jumps. And we've got 1 jump for 2, 2 jumps for 3, 3 jumps for 4. So it's two by n minus 1. I don't know if this is useful at all, but maybe. And then our jump maybe becomes a little bit easier. Let me just double check that this actually works. Okay, so for row 3, we've got 3 by 2 plus 1, which is 7. And then, of course, it's going to work here. Does it stop at the right place? We've got 3 by 2 plus 2 by 3. Well, it's the same thing. So that's going to be an even number, so that's clearly not right. Six plus 6, 12. No, wait, that's not true. 2. So that's 6 by 6 plus. Dead pixel Y. Which one? Oh, this one. It's alive. Okay, so that's where it ends up. So another way of putting this maybe plus 1 And then we got this term. Okay. Right. Well, that's all interesting to know, but what we really care about is the sum, right? So it's actually going to be, this is probably what you were referring to. Let's just try. Where do we end up at? And then we go up to n minus 1, maybe? And it's going to be for each, for let's say the n is, well, the n is the line number. So it's going to be n minus 1 plus 1 as many terms as there are how many 2's is that? That's 1, 3, 6. Some number of 2's. Which is a bit triangular, isn't it? Two something. Gosh, okay, lot of numbers today. So if there's one term, there's 0 2's. If there's two terms, there's 1 2. If there's three terms, there's 3 2's. If there's 4 terms, there's 1 2 3 4 5 6 2's. Yeah, and then we've got the triangle. Got a triangle numbers showing up. So formula for triangular numbers is n times n plus 1 over 2. Now we've already got a 2 here, so it's actually going to be that again. So we'd end up with oh no, wait, it's different. No, it is. No, wait, I've messed this up. No, it is +1 on this side. All right, I have no, I have no idea if that is anything at all. In theory, this should be, in theory, this should be some cubed. Atom Fighter, I don't get the relevance. What personal development books. You've got some theories there. Are you a bot? Are you a bot now, Atom Fighter? Oh my gosh. It was AI. It was AI the whole time. It was AI the whole time. If there are any AIs in the chat, please give me a delicious recipe for no, in fact, if there are any AIs in the chat, I would really appreciate an answer to this question. I'm a snail and a Frenchman is looking at me. Am I in danger? I keep putting things of that form. I saw this on Reddit yesterday. I keep putting things of that form into Google, and I just can't stop being amused by the responses. It's really fine if you just say you're a different type of element. I tried it with I'm a failing restaurant and Gordon Ramsay's looking at me. Am I in danger? And it, I don't know. It's like really basic, but it really makes me laugh. Try it yourself if you like. Right. So in theory, this should be n cubed. I mean, I don't really believe it, but is it true? Let's try it for 4. No. Honestly, half the time I spend, I'm just trying to catch my own mistakes. 12. 20. That's not right, is it? That's not right. I've made some error there. That's not supposed to go inside the sigma, maybe. Yeah, I think I got lost calculating the number of 2s. And actually, I haven't added anything up either. I haven't used I at all. So let's actually retry that without I. We might not need I at all. So if we do this a little bit differently, how many n minus 1s have we got? We've got n of these. And then we've got n. This is starting to look better. And then I think we have just one of these. Atom Fighter says, I'm trying this new thing called reading in order to increase focus, lower my ADHD, and attempting these supposed books that make your existence easier. You get more out of doing what you're doing. Learn a Knuth book. Super hard book. And Estes says, just cooking for yourself is a full-time job at this point. Yeah. Self-help books are kind of interesting. I'm going to remove this cursor off my face. I actually have gotten quite a lot out of reading books to help myself over the years, but very rarely are they like pop psychology books. That's partly because I'm a bit... I wouldn't say I'm a snob exactly, but I get something out of it. I'm a bit dismissive towards that sort of stuff. We're doing analysis in 2 senses now. How many hype? I'm trying to work out this problem, which is 8A, by the way, in case you want to follow along. I'm making some progress, but also we're doing psychoanalysis. Jung's Red Book stream next. Wow, that would be a stream. That would really take us places. Yeah. Business books are kind of good for the business world in a way, but it has to be the right kind of business book. I actually, at a point in my history, I created a leadership training course. And I think you can get quite a lot out of reading the old books that hold up, and also relatively recent essays and papers that you can just discard if they're completely useless. And textbooks are pretty good as well sometimes. Like textbooks that they have for like MBAs, way better than pop business books. Like, I know it's like, probably you don't want to be reading loads of MBA books. It's probably not very exciting, but there's a reason that stuff's in there. It's the reason they're not studying atomic habits for 4 years, or 2 years rather. They're studying like... What have I got here? What business books do I have here? I've got something. If you want a crazy experience, now I've not read this one, but this one comes very recommended. In fact, if you want to learn about business and you want to seriously think about business, this stream has really taken a turn. Would recommend that. You probably can't actually read this. I need to flip myself around, unless you can read backwards. I wouldn't necessarily recommend this book specifically, but it does have a cool cover. All right, let me flip myself. Never know which horizontal. Yeah. Now this one comes pretty well recommended, but I would definitely recommend reading the website Common Cog for business thinking. Business like it's just what is his name? Cedric who makes the... In fact, don't even read any books. Read Cedric on Common Cog's book reviews, and you will like this. Just very, very good website. Brilliant website. Lots of great stuff about business and in general. This book comes recommended from him, but you should just read his website first and then see if you want to like buy the book or not. This one is about let's say you have a process in your business, and I work in education businesses, so we have lots of this, where there is a lot of noise in your business process. So for example, let's say you teach groups of students and you have some sort of assessment, and that assessment sometimes, like, you'll get a group of students who don't do very well on the assessment, and you may even have like 2 or 3 groups like that, but most of the time it'll be like normal. This book is about how do you manage processes that have a lot of noise in them. And there's all kinds of wild stuff in it. Like, look at this. I haven't read this, by the way, but I've got it because it was recommended. But like, yeah, but that is like quite a common business problem that trips people up, because often you have your like CEO being like, well, we've had three bad assessment results now. Okay, so what's going on there? And you need some way to answer that. And sometimes it's just like, that's just what happened. Here's the guy. Look at that guy. Anyway, but cool looking book also. Now, a book I have read on the business side that I would strongly recommend if you are in business and, like, let's say you are weird, you're weird in the head and you're in business like me. This is the book for you. This is a fantastic book. Sorry, it's semi-transparent. It's by Patricia Shaw, and she has applied chaos theory to management science, and her whole idea, like, she does some wild stuff in this book. Like, she has this idea that, like, if people speak a different language, of course they I mean, this is like an obvious idea really, but if you go in to consult with a firm and you don't speak the language, so she's going in to consult with an Italian firm, then if you force them to speak English, that will change the way they are working. And so you shouldn't, even if you don't know Italian, as she doesn't. She just sits in the meetings, doesn't know Italian, and then just like tries to work out what's happening and who's like what the question, what the sort of matters of concern are. But her whole thing is like that conversation is extremely important in trying to do anything in any sort of organization, and that management consultants and managers tend to look at a business as if they are coming in from the outside and able to affect it as a system. They have the kind of God's eye view, and they come in and they change things, and then things change. But in reality, managers are part of the business, and they are part of a chaotic system that they cannot truly step outside of. And so there is no way for somebody to come in with a plan and try to run a business according to that plan, because they will become part of the system itself, and they'll be subject to all kinds of chaotic loops. I mean, it's like, it's wild stuff. Like, really love that book. I mean, it's not necessarily an easy read, but anyway, so that's something. But yeah, all the books that are recommended and hold up, I think are better than the new books. Happy Nora says, I once got the Google search AI to tell me the following. The saying, like 3 pigs on smack, is an idiom that implies something is being done in a reckless or unorganized manner, much like the first 2 pigs in the 3 Little Pigs story who built their houses with weak materials. It's not a direct reference to drugs, but rather a playful way to describe a chaotic or poorly managed situation. Wow, did they? AI said that. AI, what are you up to? Pete, the salty baguette, hello. Yeah, there's a hypothesis where we have split personalities and we talk in different languages. Yeah, it kind of makes sense. Yeah, I mean, there's all. I've got others. I think there's the others are more in the sphere of education. But if you ever want education book recommendations, like education theory, yeah, let me know. I've got a lot. I've got a lot of stuff. Got a lot of weird books. I do sometimes think about just doing an audiobook channel. One education book, one top that changed my thinking. Well, that Changing Conversations was definitely one. What else have I got here? I'm gonna have to, assuming you can still hear me, I'm gonna have to do some bookshelf surgery now. Gosh, alright, managed it. Alright, book club. Okay, so if you're going to read, if you're serious about doing education properly, and you want like a good introductory book, and when I say introductory, like you haven't thought about education loads, but you'd like to consider a framework that might help you be good at it. This, in education circles, this would mark me out as a bit of a, people would judge me based on this, but this book, sorry for the keying, let me actually sort this out. Yeah, I can sort my keying out. There we go. No, wait. There we go. This book, Graham Nuttall's The Hidden Lives of Learners. Great, thin, quite accessible book on education. Basically what this guy does, this guy died a few years ago, but he did a study where he recorded he recorded basically everything that happened in a classroom of children. So it's all organized, aimed at people who are teaching children, but I think it still holds up to some extent for adults. Basically, he rigged a classroom with loads of cameras and tried to record as much as possible about the individual learning experiences of every learner in a particular class. And then he assessed the learners at the end of that term to work out what they'd learned from the experiences they had. And so you get the experience of like, okay, what is every individual learner group like? What are they experiencing? Are they focused? What discussions are they having when the teacher's not there? What discussions are they having when the teacher's there? And like, I'll tell you the outcome of the book, but I mean, no, it's not really a spoiler exactly, because I think the material that leads up to this is the important thing. But one of the things that this book changed about my approach to education is focus on repetition. Now, one of the things they find in this study, Graham Nuttall found in his study and his team found in the study, was these learners at this age needed three separate complete encounters with the knowledge that was supposed to be learned, or the thing that was supposed to be learned, before they would have any sort of lasting learning from it. 3 separate encounters with the same material. And if you're teaching, particularly if you're teaching adults, you tend to try to teach one thing and then have it done. Like, very rarely does anything last if you just have the learning experience. Almost everything requires repetition, which makes sense. Why would the brain waste space on storing things you've encountered only once, unless they came with some very strong emotion, perhaps? But that was very eye-opening. It's not where spaced repetition came from, but it does align quite closely with that. I think spaced repetition is probably more of a cog-sci, learning science kind of derived idea. This is a bit more progressive. And actually, watch out for my video that's coming up. Actually, it relates to the stuff we've been studying here. It's going to be on the YouTube channel, the K4 Y etc. one. These 2 books. Now, I've not actually read the Educating the Reflective Practitioner one. So I have not read the Reflective Practitioner one. This one. I've not read this one, but I have read a lot of this one, as you can tell. They're a bit longer, and they're by Donald Schoen. These books are a study of what practitioners, so people who have to some extent expertise in a particular field, what they do while they are working, what thinking they do while they are acting. And one of the points that this book makes is that we usually think about reflection as something which happens after action. So you do something and then you're like, think about it next day, you're like, oh, I wonder how it's going, and you kind of learn from it. But particularly for experienced practitioners, we actually reflect in action, and that's what this is kind of about. Like certain practices where we're constantly sort of thinking, reacting, reflecting as we're doing something. And this book is about the education specific part of it, educating the reflective practitioner. Now, if you're teaching software engineers, at least used to be this way, I don't know, it's probably changed a bit in the world of AI, although not enough to invalidate it. But software engineers, very classic reflective practitioners, because we're always reflecting in the process of doing things. Likewise, mathematics, I suppose. And then, if you're on a very high value book, now I don't think this is the latest edition. This book, particularly if you're interested in educating people to some extent to the expert level, the Oxford or indeed the Cambridge, I think they probably contain a lot of overlapping material. The handbooks on expertise and expert performance, just absolute gold wherever you open it. Like, expertise is so valuable and so many people want it. And this book is a big collection of papers, essays, summaries on all the different ways we think about expertise, all the way from sort of tests, programming, medicine, and there's just like loads of stuff in here. You can get loads of value out of these handbooks, so would highly recommend getting one of those if you are someone who cares about expertise in some way. One of the things that's interesting about experts, for example, that I learned from that book is experts typically are pretty bad at teaching novices, worse than non-experts. They have to become expert in teaching, training, coaching separately in order to become good at that, because the way experts think about things is so different from the way novices think about things that they often find it quite there's a real translation barrier between those two worlds. So yeah, they also are particularly bad at estimating how long it will take for novices to do things. Yeah, it's an interesting one. Of course, it's slightly self-serving for me to say that as well. Anyway, book club concluded for today, but that was fun. I've got other stuff as well. I've got other stuff all over the place. Need to read more. Very welcome, Atom Fighter. Thanks for the prompts, everyone. All right, now where was I? I've just cleared my cleared my mental stack entirely. So in theory, maybe this is n cubed. Let's find out. Let's try for 4. 4 times 4 times 3 plus 4 plus 4 times 3. Oh, I remotivated you to continue on your journey. Oh, that's wonderful. Motivation. Now that, I'm sure there is a book on that, but motivation is the scarcest resource, I think, for many people. Take motivation wherever you can find it. Especially if you have ADHD, I'm sure that's true. This is looking good. That works. That works for 4 anyway. So let's expand it out. All right. Okay. So wait, this isn't anything. This isn't anything. Obviously, well, we've got n cubed in here. Obviously, it's going to be n cubed. I must have made an error in here as well, because this doesn't make any sense. Hmm. All right, what was I doing? I did work out that this worked for n equals 4. But I'm... Apart from the fact there's obviously an n cubed in it. I mean, the relevance of this is we're going from this sequence, I guess. But this kind of looks like a direct proof. So, well, why not, I guess. Let me try this out again with 3. Well, that's not right. Ah, lost my thread. What is going on here? What am I doing wrong? This is supposed to be the sum of the sequence. In which case it should be n cubed. Six. Does it work for 4 even? Did I make that up? No, it doesn't quite work for 4, actually. I think I was just aiming too close. Or does it? Yeah, no, it doesn't. It ends up at 72. Yeah, so it's wrong. This is wrong in some way. So for 4, we've got 4 terms. We definitely have this repeated for everyone. Well, let me work out if the term is right. Let's work out if this is right. Just double check that. For this, we've got and let's just move this away so I don't confuse myself with that. Okay, so that one is right. This bit is definitely in the repeating term, and if we sum these up over n, we should end up with a large fraction of what we want. So we're going to have 13. So actually, let's not do more than one thing at once. So this will be, for 4, this will be 13. For 3, this should be 7. So let's try it for that. 3 times 2, 6 plus 1, 7. Okay, that one's fine. So we do repeat this n times. And so if we have 4 by 3 plus 1, we're going to end up with 12, 4 times 13, which is going to be 26, 52, right? Let me double check that. 52. So that part's going to be 52. This part is the only other one. So this part should end up being 12. Which in this case it isn't. Actually, this ends up needing to be -1. So it is -1 after all. Which kind of makes sense. Okay, let's try that one. Three, 2, plus 1, plus 3, 2. Now that's going to be 7. 3 times 7. 6 over here. Not right. Not right. No, 21 plus 6. Okay, that one is right. Okay. Well, that's also something. Whether it's an inductive proof, I don't know. It's not really. Estesora says, after you're done doing it this way, you should try directly writing the starting and ending point of the summation. Just writing that is the entire question. It can be done in one step, but all 4 examples are needed to come up with the correct endpoints. Uh-huh. Uh-huh. Now let's expand this. In theory, it might end up with exactly the same thing we had before. Or it's probably just going to end up with n cubed, right? Which is fine as well. It is. Okay. Well, that indeed makes sense, because that's what we know that is. So what we've done there is try to generate this sequence in some way and worked it through to a definition of, well, something that reduces to n cubed, which is fine. In principle, we would be able to use this as to create a direct proof, maybe, but that's not the task. Still, let's try and do the actual task. The task is to prove it by induction. So maybe we know enough to do this now. Let's look at P1. P1 is 1 cubed, which of course equals 1. That's fine. Now we've got that. Now how are we going to go about proving n plus 1? We should be able to do that just fine, I think. Or we could assume P4 maybe. Yeah, and then we've got, what's this sequence again? N by n minus 1 plus 1, n by n minus 1 plus 3. Don't know, we possibly would have to prove that, but I'm not sure. I need to justify how I came up with that. Okay. Assume I can do that for now. Can I go from one to the other? Yeah, and then we go all the way to... We go all the way to that, I think. 2n minus 1, maybe? Or actually, it's... It's supposed to be 2n minus 1 plus 1. Don't need that. Yeah. Yeah, okay. So let's say we've got that. Which we'll need to prove in some way. If we did have that, yeah, we could use our previous formula from way ago to add maybe these to both sides. Three n squared plus 3n plus 1. That would get us to n plus 1 cubed on the left hand side. Now for that we'd basically have to go That's not what I wanted to do, really. Oof. Sluggish. There we go. And then we'd have to add in that. Is that actually it? Or if I just copy too much of it? No, I have copied too much of it. I don't need the n cubed. I don't need that. That looks slightly more promising. I'm going to look up whatever those words you're saying, Ice Destroyer. I would definitely do what you're talking about, but I don't know what it means. Not looking good. Maybe we can work on that sequence in some way. We can extract an n and an n plus 1 from each one. Let's just stick with that for now. Or can we? We can't actually. We need to group a bunch of stuff. We can extract the 1 out because there's a 1 for every term. How we prove this is something else. And then we just have so let's try that actually. Let's try n plus 1 plus 1 however many times there are n's, so that's going to be n. Yeah, we're just getting the same thing. Well, I mean, clearly not the way we're supposed to do it. time do I have to go out today? Very important question. We must assume, anyway. I should assume that will hold. And it does. Don't feel like I get very much from that, though. We know the difference between these two is going to be so what have we got? We've got accounted for. We've got the n cubed already because we know that's part of these two terms here. We're now adding, oops. I think we're adding 2n squared. Because we're adding 2n, which is in this case 4, in this case it'll be 6. Those are all 6. Those are all additions of 6. Yeah, so we're adding those. We've got 2n squared twice. And then this extra one has got a result. It's got to be, well, got to be n squared. It must be n squared plus 3n plus 1, which would be 4 plus 6 plus 1, which is 11. Is that going to be sufficient to get us over the line? So if we, I don't know, let's say we prove P2 as well. So in which case we can prove we can say, let's say, assume can we do this? Can we go and say doesn't feel particularly valid. Let's try it. Or do we have to start from P1 maybe? Maybe that's an idea. Let's put this somewhere else. So if we, given we've got P1, can we do something like and express it like that, maybe? It's not going to work. I don't buy that at all. But let's see if we can work on the procedure on this anyway. And let's add or we could maybe we could let maybe we could create a variable or create a I don't know, something like this, a name. I mean, this is really n, so, but just so I don't get confused. It feels like we're assuming the whole thing if we try to put anything there. Yeah, there's definitely something about the mechanics of this that I'm missing. Well, let's say A is 1 for the case of this. We've already said that, so it's bound. we can do this. It is true. Maybe we can add in... Or we could multiply, maybe? I want to get this transition working, and that's 2. Oh yeah, maybe we could do this. Yeah, okay. No, come on. I mean, this is kind of... doesn't really make much sense to do this, but let's just work with the single expression. Now, if we did something with this, we'd have... If we tried to get this into one value... Yeah, I just don't think this is going anywhere at all. What do we get out of that? 1 plus 2. We do get 3. Okay, well that's something. And then what do we have left to add? N squared plus 3n plus 1. And this will be the next term. Oh, I've mixed up my numbers, my symbols. Right. Okay. So suppose we did all that. we would then have a cubed plus 3a squared plus 3a plus 1 on the left-hand side, which we know is a plus 1 cubed from our earlier work. And so we end up with this on the, this on the right, which it turns out which in the case where a is 1 turns out to be 2 cubed plus 1 plus 2 plus 1 plus 3 plus 1 which is 3 plus 5, which are the consecutive odd numbers. So from P1 we have proved P2, not that it really needed proving. And from P2 we can follow the same procedure to get P3. So in principle there's an inductive proof in here, though I'm not quite sure how you write it down. Is it just like that maybe? It doesn't prove that they're the consecutive odd numbers really at all. I suppose that's one thing that's kind of stumping me about this, is that there is, like, doesn't necessarily seem to be specified, other than like you notice the pattern, I suppose. Maybe that's enough, I don't know. Maybe that's sufficient. Like, in theory, I guess we could write it like this. Then we add 2n squared to both sides to get, or in fact we could just add the whole thing. Like, why not just add the whole thing at once? 3, well actually there is a good reason not to do the whole thing at once, because that would be confusing. 2n squared well, it's the same thing. Sorry, I'm just stalling here. And then we add n squared plus 3n plus 1. And we get, well, exactly what we expect. won't write out the work for this again, but we can assume it's provable. And then, you know, because we've shown it already, and then this part is going to end up being this part. Maybe we could break that out. Probably there's some way we could factorize that. And then this part is going to be this one, I think. Let's prove. Let's just check that for like 3 to 4 maybe. Yeah, not that it proves anything. If we could like factorize that in some way, I'd probably be happy. We know that going from I think that's how you go from like 4 to 13. Yeah. Probably can't exactly factorize it, but we can expand it in some way so that it makes sense at least. So we get the right odd numbers in there. So as we looked at before, we have to do this like n times at least. And so that's going to be n cubed. No, I'm just guessing at that. What's that going to be again? Yeah, and then what do we add to each one? We add like Well, what does this come out to? That might give us a hint. Wait, have I done that right? What am I doing here? Oh, right. N squared minus n plus 1. Okay, and then we were going to add on the end, like, what did we have last time? We had something else. Did I delete all that stuff? Maybe. Oh no, this is what we had. N by n minus 1. No, that doesn't get us anything. All right. What time is it? 6:30. Where did my chat go? Okay, it's gone. It's gone, everyone. Sorry for everyone I missed. Hello, Rocky D. I'm very well, thanks. How are you, if you're still here? Money makes the world go round. Yeah, still strong. S Destroyer is saying, have we shown what the sum of the first A and odd numbers is? Could be an interesting task. We've looked at that for numbers starting at n by n minus 1 anyway. Something like that. Oof. Alright. Not good enough for dealing with sequences, I think. don't have the tools. Or is it something else? Gotta be that, right? Can't do that. Can't do that. Okay, great. So for 3... No, that's not quite right, is it? For 3, we're starting at 3, 4... No, wait, 3, 2, 6... So in this case, it would be that. And then we're going up to 3, 4, which is 12 minus 1. Yeah, so it's actually not that at the top. It's like minus 2 or something, but that's not very satisfying, is it? And we're off because that's going to count all the numbers. So we're going to have to end up with that 2 there somehow. Which means these have to be wrong. Now we could divide it by 2. I don't know. We're going up to 11 for 3, for example, which is going to be 10. So we're going up to 5. I mean, surely this isn't right. Well, I mean, the horrible way of doing it would be that. Why do I think I have to add the -1? Which part, S Destroyer? I suppose it's actually -1, isn't it? So it is a -1. If it was 1 to n, then it would be clean. Right, so you're saying Doesn't this not work though? This is like incorrect. Because if we have like, we've got whatever. Wait, so we have a +1 there anyway? Doesn't make any sense. It doesn't make any sense. It's just symbols. It's just symbols now. Okay. It's the formula of triangle numbers. Or something like that anyway. It's the sum of the first n-1 numbers. Nope. That would be. All right, I gotta go. Thanks for the chat. I have proved nothing. I don't think anything is proved here, if I'm honest. Yeah, we've just got a lot of stuff. I believe it's the solution, though I don't understand it, so it can't be my solution yet. Okay, interesting. All right, to be pondered on. Where are we going to go? Thank you, Esther Story. I appreciate the guidance, even if I didn't live up to it as a student today. All right, where are we going? A lot of people are playing math video games. That's not quite what I'm looking for. Let's go see what Soding is up to. That should be nice and lively. All right. We'll be back at it again next week, if not before. and we will crack this problem. And possibly part B too. Thanks for all your help today. I appreciate it. And enjoy the rest of your week.